We're in module number 11, and here in module 11, we're going to talk about session hijacking. Let's jump in. With session hijacking, we're going to look at several different areas, starting with just conceptually in the first objective, and then we're going to look at two major types of session hijacking, including application in number 2, and number 3, we're going to be looking at network session hijacking. And then we're going to look at some common countermeasures for session hijacking. So let's have a look at what session hijacking is. What is it? In this slide here, you can see that we have an attacker. You can tell it's an attacker because he has a hoodie and a mask, I think. But what happens if you look at the communication, we see several things going on over here. Let me use my highlighter. And so we see that there are credentials involved. We see there's a session setup involved. There's data that's being requested and transmitted. And what's happening down here? What's this attacker doing? Sniffing that traffic. So they have a network card that's in promiscuous mode, and they're gathering all that information. What do you notice is missing here? Why is this attacker able to even do this? They shouldn't be able to get this information, but what's happening? There's no encryption. And we'll see that that's one of the major reasons that session hijacking works. All right, so let's look at it from the bottom up. So we're going to start with the bottom down here. And so what the attacker is going to do is they're going to place themselves in an area where they can monitor the traffic. So here's the attacker down here at the bottom, and they are able to look at the transactional traffic between their target over here and the server over there. Then the next thing that's going to do, he's going to monitor the flow of packets. And here's a very important word here, predict. And another pair of important words, the sequence number. So he's going to be watching that TCP sequence number. And then what he's going to do is desynchronization. He's going to break that connection that goes out to the victim's machine. And then because he was able to predict the session ID, he's able to take over the section. And then what he's going to do with that session is start doing what? Injecting packets. What do I mean? Well, he does whatever he wants, depending on the level of takeover. And so that's the process that's happening with a session hijacking. So with session hijacking, it takes place at a couple different areas of the OSI model. One area at the top is the network level, where we're looking at TCP or UDP. Right above the network layer, right, we have layer 3, which is network, and then our session layer is a layer 4. And then also at the application layer, which is going to be layer 7 of the OSI, and they're looking at HTTP in this case. All right, so we need to get something straight here. We're not just talking about spoofing. What spoofing is when I can change my IP or MAC address or whatever, and I can pretend to be another user and steal things. I'm not actually taking control of a session. What I'm doing is hijacking. So in this case, there's an active, legitimate session between a device and a web server and taking over that session. So that's what we're talking about in this module, is actually session hijacking. We're now in objective number 2, where we're going to look at a specific type of session hijacking. Our first one that we see here, we'll get into networking next, but we're in application session hijacking. So at the application level, there are many things that can happen. If you look over here, what we're going to be doing is predicting the session token. We're going to compromise those session IDs by sniffing. We're going to predict where it's going. How does that work? Well, let's have a look at how these types of systems work. What we are assuming here is a couple of different things. Number one, we have a connection from, let's say, my laptop to a web server, right? And that connection has been established at the TCP three-way handshake. Now I'm transmitting and receiving packets through that connection. And so let's have a look at the different token patterns that those connections can take. We go over here and we see that we have sequential tokens. So this is a constant, so this doesn't change. But if you look at the other number associated with this token, it increments. We see that 1, 2, 3, 4 on this column. And so that's fairly easy to predict. Another one would be small token space. So if we look here, especially if we're only dealing with 2 characters, but even 4 is fairly small of a space for a brute force attack, so we can brute force the next token. Also, we go over here to the far right of the screen, and we see we have several things. A constant, we have a date. So we analyze this, and we say, that's a date. Okay, got that. That's today's date. And then we have a time, the character T, and then as we go through seconds and minutes, that changes. Okay, we have a time. So now I can predict the next time and date and predict that session token. So why is it possible to do this? Number one, down here is lack of rate limiting. So without rate limiting, you can make a whole bunch of tokens. You can guess, you can try over and over again, and you're not going to be blocked. So that's good for the attacker. And the other one is, we'll see this, by the way, when we get to 2 areas. When we get to Wi-Fi and hacking Wi-Fi, we're going to get into random number generators, specifically PRNG. And so with predictable PRNGs, you can produce the token sequences because it's highly predictable. So these are reasons that we can predict that session token. And if we can predict it, and with spoofing that IP address, then we can take over that session. And that is what we're doing in this section. All right, so once we have predicted that session token, then we can take over that session. And so this guy's on his computer system, having a good old time. He's connected to a web app. Little does he know that the attacker is predicting that session ID and then spoofing it, the IP address of the victim, and then getting the next communication as if it's going to that victim. Instead, it's going to the attacker, and the attacker is essentially doing an MITM in between those two. All right, so we have the ability to compromise session IDs also using a man-in-the-browser manipulation. This one is actually pretty fascinating. Let's see how this works. So this is an MITB, man-in-the-browser. How did this even start? Well, somebody was surfing around the internet, and somehow they got a Trojan horse. What it's doing is it's intercepting calls between the browser and its security. So the security is essentially off for this Trojan horse. So that's the number one, that's the infection. Number two, there is a malicious code and extension that's installed in the browser. Number three, so the user fires up the browser, uses it, that extension is turned on. Number four, there's a handler. What is a handler? A handler will react under certain circumstances. So for instance, on click, off click, mouse move, or whatever. So there's a handler that runs every time you visit a web page. But what web page? Number five, there's a targeted list. So it might have a list, for instance, of financial institutions of various types. It could be thousands of financial institutions. So now I'm the user, and I go and I log in to my financial institution website. And now, oh, hey, that handler says, hey, there's an event. There's an event. They're going to that website. So now what I do is I click on a button, and the DOM, uses DOM. This is a model that's used in HTTP to manage page objects. We extract and modify data. So I go to my bank or whatever, and let's say I want to transfer $10 from checking to savings. So I run that transaction, and in the background, this malware is draining all of my money and doing a bank-to-bank transfer. But in the foreground, it says, congratulations, you've transferred $10. It looks perfectly normal. So after the server performs a transaction, that nice receipt looks perfectly normal, is generated. But in the background, there was a modified transaction, and the user is none the wiser. It's crazy. So the next one we're going to talk about is session replay. And one thing I want to say about this is this does not work that well, but it works under certain circumstances. So what's going to happen is the attacker is going to be sniffing and gathering that communication between the user and their session. And then later on, they're going to replay it back to get access to that server. Doesn't always work, but it's always a possibility. The next one we're going to look at is one of a class of attacks where the attacker essentially gives the target of their attack the information, the session ID, the token to communicate. So if you look here, number one is we're going to start off with an entice to click. So they click on that link, and then what happens next is they log into a vulnerable server, and look what we see here. They have a cookie. Where did they get that cookie? Where did they get the SID? They got it from the attacker. So they lure that user to authenticate themselves with a known session ID. They get this from the attacker. And so that known SID then is used for that server, and then the attacker is able to log in whenever they want. So what you want to remember with a session fixation is that the attacker provides a valid SID and lures them to authenticate using that SID. And since the attacker knows the SID, and I keep saying SID, that stands for security ID, then the attacker can use that session whenever they want. The next thing we look at is proxy servers. So again, this is going to start with an entice to click. So we click on this link, and the next thing that happens is we change the LAN settings on this victim's computer system so that go through the attacker's proxy server, and they can do whatever they want with that session. All right, so I want to report a crime. It's a crime attack, right? This is the compression ratio info leak made easy. Compression ratio info leak made easy. Now, think about protocols and types of applications that use compression. When I think of that, I think of stuff like JPEG or GIF or MP3, MP4, things like that. But also SSL, TLS, SPDY, and by extension HTTPS use compression. And so what's going to happen in this case is the attacker is going to be able to attack that compression and get information from the session cookies to establish a new session based upon the previous session. And so what you'll see there is, we again are going to start with a malicious link that has the JavaScript for the crime attack. And then they're going to use that. And if you look over here, you'll see that they're decrypting a bit at a time, and they finally decrypt the entire session, and they're able to run the attack from there. So that's what we're doing with the crime attack. The next one is verboten. You can't do that. It's forbidden. What is it that you can't do? Well, what it is that you can't do, or you shouldn't do, or you shouldn't be able to do, is reuse a cryptographic nonce. What does the word nonce mean? I'm going to renoncify. So that word I just used, renoncify, you'll never hear that word again. It's only one time that I've made it up. No one knows about it. That's the word. So that is a nonce word, is something that is ever only used once. In the case of cryptographic nonce, it's only ever used once. So what's going to happen in this case is we're going to reuse that cryptographic nonce. That should never happen. Where is it going to be reused? In that TLS handshake. So what's going to happen is the the victim is going to do a TLS handshake. They're going to establish HTTPS. The attacker is sniffing that. They use that nonce that they found, and then they are now able to see that traffic and decrypt it because they have the cryptographic nonce and they can see the information. So, by the way, this is going to come up again in wireless. See if you can do a little lookup and find out what other types of attacks make use of or reuse of cryptographic nonce. All right, another one is a session donation. This is yet another class of attack where the attacker gives their victim the credential so that where the victim goes, they now have access to those resources. So what's going to happen is the first thing that the attacker is going to do right over here is they're going to log into a service, establish a legit session. So they're there, it's legitimate. They're going to get from that server a legitimate security ID. Now that they have a legitimate security ID, they're going to be nice and friendly. What do you do when you're nice and friendly and a giving person? Well, you donate. They're going to donate this SID to this user. And so we have an entice to click. They click on it. Now what's going to happen? Well, the user is going to click on that link and they're going to enter their details and save it. And now what's going to happen is the attacker is going to be able to log in and get all the information that the victim has given them. So yeah, they make it so that wherever this victim goes, specifically to that crafted link, they can capture information from that victim. Welcome to section 3, where we look at network level hijacking. So in this case, we've finished application level hijacking, and we're going to see another level of session hijacking. Let's have a look. With network level session hijacking, we're looking at the network level and on up, but mainly focusing on the network level. There are several different things we're going to be looking at: blind, UDP, TCP/IP, which we've already seen a little bit of, RST, that's one of those TCP flags, man in the middle, MITM, packet sniffers, and also IP spoofing and using source routing. Let's have a look at the first one. So the first one we're going to focus on is what in the world is TCP/IP hijacking? I think this should look familiar to you, all of this, because we've talked about it over and over again. Here's the three-way handshake. And with the three-way handshake, we have the sequencing and acknowledging that takes place after that as data is being transmitted. But meanwhile, in a hoodie, there is an attacker. And so before the user sends the next packet, this attacker with a sniffer or some software is going to be predicting that next token ID, the token session information, and they're going to be able to take over and hijack that communication. There's another way, and we're going to see this in a couple of other areas too. This is called source routing. I think we already talked about it in one of our previous modules, but in source routing, you don't like the router, the path that your packets are taking, just choose another one. So what we want to do is get unauthorized access, and what we're going to do is spoof the host IP address in order to get that server session. And then when the session is established, we can inject forged packets into that server. And then from there, we're able to predict sequence numbers. And then from there, we can source route through that device into the destination IP. So that's one of many different methods to do source routing. The next thing we want to look at is RST hijacking. RST is a flag that we get in that little TCP datagram that after a TCP three-way handshake, anywhere after that, we can reset the connection. And the way we do this is called packet crafting. We use tools like Colosoft Packet Builder in order to send this reset package. When we send the reset packet, what it does is it cancels that connection. So in this case, what happens is this user sends data. If you examine it, you can use Wireshark or many other tools. You can zoom in on what they are sending, and they have their source and destination. The source is the user. The destination is the server. There's a sequence and acknowledgement number and a length, and there are other things that happen with this packet. There's a response back from the server with the same source and destination, but with the IP addresses reversed with a sequence and acknowledgement number. But in between this communication, the attacker spoofs the IP address of the server machine, and then they can predict the next acknowledgement number and reset that connection and take over that connection. So that is called RST hijacking. And when I talk about some of these things, don't think that there's an attacker kind of looking at packets with his finger hovered over a button to do the reset. No, this is going to be done in the background with software. The next thing we look at then is blind and UDP hijacking. We're going to get into a lot of blind types of attacks when we get into hijacking and doing SQL injection. So we do SQL injection, we'll look at that. But what blind means is that you don't see a direct response from the device that you are attacking. So in this case, what's going to happen is there's going to be a request that's sent, intercepted by the attacker. The attacker is going to send some type of a crafted response to the server, and rather than responding to the attacker, it responds back to the victim. So the attacker doesn't see what is happening. So what you do normally in a blind attack is you have to look for the after effects of the attack. We have another one too, UDP hijacking. UDP is a little bit easier because unlike TCP, it's not sequenced and acknowledged. So you can more easily do a man-in-the-middle attack. So what's going to happen is the client's going to send a UDP request. There's going to be a UDP response. The attacker's going to sniff that and forge the reply before the server does. It's just going to be a little bit faster. And so the client sees something different. So that is a UDP attack. And again, a little bit easier because you don't have to worry about sequence numbers. You don't have to worry about acknowledgments. All right, what about an ICMP and ARP spoof? We're going to forge those with that attack. It's a man-in-the-middle attack. So one of them involves a forged Internet Control Message Protocol, or ICMP communication. So what they're going to do in this case is they're going to be using a sniffer, and they're going to make that sniffer the interface between the client and the server, changing the default gateway, the client's machine, and then try to reroute those packets. And so this is just an extension of ICMP over here on the left, where we send error messages. That's what ICMP does. And if you send the right error messages, you can cause the machine to which you send the error messages to behave differently. And so that's what we're doing here. Imagine, for instance, as a very simple version of this, we have the ICMP echo and reply, right? So if I send out a ping and it comes back and there is no reply, then my machine might respond differently than if there is a reply. So we can forge that ICMP to change that response. And then we have ARP, Address Resolution Protocol spoofing. And this is going to be at the network layer. And we're going to change how ARP responds. We already saw this before in a previous module, and we're going to see it again. Both of these can be spoofed and used to get in the middle of that conversation and hijack the path between those two machines. There's another one called pettypotem. Pettypotem is an attack that takes place on a domain controller. We've already talked a little bit about some domain controller attacks, but I want to focus on the technology that this is a part of, and that is Microsoft's Encrypting File System Remote Protocol, API. And there's another thing I want you to know about this. They're going to relay NTLM authentication. So again, we're using NTLM authentication. So this is what makes this possible. In fact, if you look down here, in some versions of this, you'll see this even says NTLM v1. So another thing that we're going to make use of for this attack is a certificate server. So that's part of a PKI normally that you'd have in a certificate hierarchy on a domain, and it's going to generate a certificate. And what we're trying to do with the petty totem is get admin access. So let's look at how this works. So we have a legitimate users. What is this again that we have? We have NTLM credentials. So again, using NTLM opens you up to a variety of attacks. So anyway, we provide those credentials for authentication. We get a response back. This is the EFS, encrypting file system, RPC, remote procedure call, open file raw, and that's the attacker's SMB, server message block, like you're sharing a folder, server address. So we get both of those. And what the reply we get from the server, it doesn't necessarily have to be a domain controller, but we get a reply back that is the NTLM authentication, and then we can use that NTLM authentication reply and generate a certificate from the certificate server, and then I can use admin level privileges. So that's petty totem hijacking. Now, what about tools? Because like I was saying before, we don't do these types of hijacks just by watching packets go. They go by too fast. There are too many of them. So what we want is session hijacking tools. Hetty is one of them, and it does nice machine in the middle hijack. Very nice. This gets updated fairly often. It's a nice tool. Another one is Kaido. Kaido is an auditing toolkit that you can use to intercept HTTP requests. And we have a few others here that I want to talk about. Down here is BetterCap. Two tools that I would like you to get familiar with. We'll also see them in the lab is EtterCap and BetterCap. BetterCap is great for man-in-the-middle attacks. Another tool I want you to be familiar with, that's OWASP Zap. It's free, it's open source, and it will help you examine communications between a workstation and a server. And it'll act as a proxy. You can watch as everything goes. You can open up the HTML, the page, read the header information and all that kind of stuff. We'll see that when we get to attacking web applications. WebSpite framework, very good. We're going to see that again when we get to web applications. SSL strip. This is a nice little tool. What SSL strip will do is, let's say there is an application that's running HTTPS. What SSL strip will do is contact the server and say, hey server, you know, I really can't do HTTPS. I can only do HTTP. And the server will say, all right, little buddy, I'll help you out. I'll switch to HTTP for you. And then SSL strip will say, thank you very much. And they'll start laughing and hacking that. So you're not really hacking with it. What you're doing is you're switching that web server to HTTP from HTTPS, and then you can run a hack at the HTTP level. In fact, SSL strip is very nice for MITMs, man-in-the-middle attacks, because you can't do man-in-the-middle attacks very easily with HTTPS. Now, the next one I want to talk a little bit about is Burp Suite. Burp Suite is the preeminent web app hacking tool. It has much better capabilities than its competitor, OWASP Zap. Although Burp Suite has a community edition, OWASP Zap is free and open source. So if you want the full edition of Burp Suite, you have to pay money. Portswigger is an amazing company. And when we get to hacking applications, I'm going to suggest that you learn as much about Burp Suite as possible. So I just had to talk about some of that because these are really cool tools. We are now in the last section here. This is section objective 04. We're going to be explaining hijacking countermeasures. So you don't want to be hijacked. You don't want your session hijacked. What do? Let's have a look. So some protections. You know what the main thing is? And you're going to see this in a few different areas, but that is ubiquitous encryption. So over here on number 1, we see SSH. On number 4, we see encryption here in defense in depth. Over here, we see VPNs. So we see encryption all over this. The next thing that we need is ubiquitous IAM, or authentication. And so over here we see that we have the logout functionality. What's that logout, login? Well, that's authentication. So we want to make sure you get logged out. Over here we have Kerberos, which is authentication. And so we have multiple areas where we need authentication. And then after that, it is to make your session less hackable by having session timeouts and by making your session token less predictable. And then there are tools that you can use to detect session hijacking. Over here on the left, you have USM. This is Alien Vault. They make this. It has a lot of capabilities, not just session hijacking detection, but it does that also on the cloud, on premise. Over here, we've talked about Wireshark many times before. If you've followed me in the labs, we've used it many times before. It's a tool that you need to get very good with. And then we have intrusion prevention systems from Checkpoint like Quantum. We have SIMS, a security event manager from SolarWinds. We have IBM. They make a lot of good stuff here, their network intrusion prevention. So we have tools that we can use to prevent or detect intrusions. The next thing we want to do is prevent hijacking. And what we want to look at in this case are some approaches to doing that. So what we're going to see with all of these is we want to make sure that if a workstation, a browser, a user establishes a connection, that nobody else, nothing else, can also establish the same connection. So one of those would be HSTS. HSTS is HTTP Strict Transport Security. What it does is it enforces, it makes sure that this web browser of this client is the only browser that can contact that web server. So if I'm sniffing that and I try to use my computer, it won't because I have HSTS. Another one is token binding. So with token binding, when a user logs into the application, we get a cookie, we get a SID. So this is the token. And because that token is set up, only that browser can contact that web server. So if I'm attacking that service, I'm another browser, another entity, and I won't be allowed to do so. So if we want to prevent these types of attacks, encryption, ubiquitous encryption. So even for DNS, you can put DNS over HTTPS. That's called DOH. I kind of like that. You know what that acronym stands for? Duh. So DNS over HTTPS. And so that way people can't sniff that DNS. And another one is IPsec. IPsec is not just a protocol. It's actually a suite of protocols. I think we've talked about that a little bit before, often used for VPN to give you remote access, but it provides a couple of different things. It provides authentication and confidentiality. And with IPsec, it actually has two different modes. One is the AH or authentication header, and the other one is ESP or encapsulating security payload. And so the one at the bottom, ESP, is normally what we think of with IPsec because it encrypts the payload. But did you know that you can install and set up IPsec with just authentication and no encryption? Yeah, you can actually do that. But that's the authentication and encryption, network peer authentication, data origin authentication, data integrity, confidentiality, replay protection. All of that are some of the benefits that IPsec can provide for you. If you look at IPsec, what I was talking about a little bit earlier is the encryption using ESP. And if you look at the encryption here for transport mode, the original header is not encrypted. Ergo, therefore, I can send these all around the internet. So if you're using a VPN that's run through IPsec and you're able to move around the internet, then you're using transport mode. You can transport it around the internet. But if you encapsulate the entire packet, then you'll need to have a point-to-point connection between two gateways. And at one end, that entire packet is encrypted, it's sent to the other end and then decrypted. So that would be tunnel mode. So like I said, there are many moving parts to IPsec. There's AH, there's ESP. There are multiple encryption algorithms, AES, 3DES, authentication algorithms. There are multiple ones. You also have just a whole series of algorithms that you can use. There's domain of interpretation, key management, policies, and more. This is kind of an overview of the IPsec architecture. There's a lot you can change and work with. But if you're running IPsec, and especially even if you're running just AH, but if you're running AH with ESP, it is extremely unlikely that someone's going to be able to do a man-in-the-middle attack on that communication. All right, so we talked about session hijacking. Session hijacking leads to things like man-in-the-middle attacks, allows an attacker to be able to extract important information from communications, maybe even personal details, credit card information, or in some cases, be able to do arbitrary actions against whatever it is that is happening in that session. And we see that most of the countermeasures that we use for session hijacking involve encryption and authentication. So if you have encryption and authentication, and they're both very good encryption and good and well implemented authentication, then even if you're not managing your session tokens that well, you're still less likely to be attacked. So all of these things go into session hijacking, and we're going to do some lab work. And that's it, I guess, for this module. We'll join you in the next one.